The Symbionicsphere, engineering biogeochemical symbiosis with the Biosphere. Solo author Nathaniel M. Zaplatar. Abstract. The following research paper and PhD dissertation prospectus describes a new theoretical framework and a Kuhnian scientific revolution in environmental engineering, urban ecology, ecological facade, and/or biomimetic-inspired architecture. This paper principally serves as an outline for advanced ecological planetary cybernetics information and control theory. It is also intended to describe and demonstrate how to design, experiment, and implement ecologically integrated bionic or prosthetic systems. It is a radically different, albeit inspired approach to traditional biomimicry, ecosystem biomimicry, and traditional sustainability in general. Symbionics, or Urban Ecological Niche Prosthetics, UENP, as a whole has now completely departed almost altogether with sustainable, or sometimes called green or blue architecture, civil engineering, energy production and distribution, modern communications, housing, food production, waste management, hygiene, transportation, etc., presenting an alternative goal to merely sustaining our current impact on the Earth towards functionally translating biological and ecological symbiosis as found in nature. In other words, an advanced eco-industrial production and active maintenance tending towards eventual absolute ecological homeostasis. Symbiotic UENP engineering or class of technologies, whether single devices or modular component systems, are theorized to succeed starting from regional ecological hemispheres, biomes, and then eventually scaled up to the global level, biosphere. These symbiotic technologies and prosthetic architectures are an ecocentric lens for human urban and industrial homeostasis that will be realized through ecologically interactive systems that facilitate dynamic information flow and control between the built and natural environments. The foundation of this eco-industrial homeostasis is based on the theory of architectural and industrial systems capable of participating in the biogeochemical cycles of the Earth themselves and over time enhancing their health, vitality, and life-conducive properties of all modern urban and industrial technologies required to maintain our collective standard of living. This urban and natural biogeochemical homeostatic symbiosis is specially designed to convert the very urban, industrial, communication systems and waste management practices that are now the primary causes of global warming and the climate crisis, otherwise known as the sixth mass extinction or the Anthropocene. It is still debated among climate experts if our traditional methods of city building or urban development models has now eclipsed the overall contribution to the climate and biodiversity crises, or immediately follows right behind military, transportation, and industrial manufacturing and shipping produced CO2 and methane pollution. In either case, urban or city-based development is contributing to a massive planetary chronic ecological metabolic imbalance. It is the first goal of this research paper to describe to the reader how we can go about designing urban, industrial, waste treatment, computation, and information or data, and by extension, economic systems that can allow for the biogeochemical cyclical participation of these symbiotic architectural structures and eco-industrial technologies as the primary means of rapid ecological and biodiversity regeneration. This gradualist and then carefully accelerated ecological regeneration occurs at the very sites of the urban and industrial cores that are readily identified today as the primary causes of the planetary ecological crisis. This new general engineering theory of ecologically integrated, physical metabolic, ecological, biodiversity, regenerative architectural and industrial, mechanical, living mechanical, agroecological and biotechnological material and energy technologies are consciously designed as semi-closed or controlled open system. Inspired feedback loops is called Symbionics, is the conjunction of the words symbiosis and bionics with the full technical name and acronym of Symbionics or Symbionic UUENP. Engineering is Urban Ecological Niche Prosthetics UNP. This research paper will be using this acronym as the full descriptive term of Symbionics or Symbiotic Engineering and will be used interchangeably with its shorthand name. Finally, the primary intent of this research paper will be to describe the overarching or unifying meta-theory encapsulated in the title of this subject introductory paper describing of how all the separate inventions and components that I have carefully conceptualized and theorized can be constituted into a unified whole, starting at the regional biome levels all the way up to the global biosphere of the Earth. This integrated system designed for symbiotic or UENP systems theory for all of my inventions, whether single devices or whole eco-mechanical systems for my body of theory, is called the Symbionicsphere. The Symbionicsphere is the name consciously derived from the scientific and science historical legacies of the theories of the Biosphere and Noosphere as described first by the Austrian geologist Eduard Suess, 1831–1914. However, this research paper will be analyzing the biosphere theory primarily described in scientific terms by the Soviet Ukrainian-Russian founder of modern biogeochemistry, Vladimir Vernadsky, 1863–1945. The Symbionicsphere theory is also rooted in the accompanying concept of a planetary sphere of conscious thought, called the noosphere that Vernadsky originally outlined, but was then further described and then later expanded upon conceptually by Pierre Teilhard de Chardin. The noosphere was, as described by Vernadsky and Chardin, as the planetary sphere of consciousness made from the sum of all actions based on human thought, like the imagination or the entire conscious layer of the biosphere itself, derived from all living creatures on Earth, but primarily shaped, as mentioned, by collective human thought's capacity to shape the planet. The Symbionicsphere theory is also conceptually linked and overlaps to a lesser extent with the independent scientist, environmentalist, and futurist James Lovelock and his famous Gaia hypothesis that describes the Earth as a unified, self-regulating superorganism. In this line of thinking, the Symbionicsphere can be defined or loosely described as the interconnected planetary ecological prosthetic skin or planet-wide membranes of the noosphere that consciously acts to self-integrate into the macro and micro ecosystems that constitute the biosphere in order to stabilize and heal it. This research paper will also conclude by demonstrating how more than theoretically, Symbionic's UENP arguably suggests a superior framework to traditional sustainability. This theoretical advance was realized by moving beyond doing possibly less ecological damage in a more benign fashion contained within a still otherwise hyper-extractive, linear, short-termist-driven, and high-entropy context. Globalized capitalism. While presenting the first embryonic experiments, the theoretical and practical framework to engineer full human architectural, agricultural, industrial, manufacturing, basic infrastructure, energy sources, communication, and information systems into full metabolic symbiosis between pre-existing built environments and their surrounding natural environments. This novel theoretical engineering framework already shows documented potential for more advanced applied science in the near future if invested in and taken seriously by ecological, biological, architectural, and computer science experts. The theory. At its core, the theory of symbionics, or urban ecological niche prosthetics, UENP, describes a new departure or substitutive approach to traditional environmental engineering and ecological restoration, centered around the idea of the eventual phased, full-scale civilization conversion, starting with the unique refitting method developed for this exact purpose, referred to as symbionic, or UENP, building envelope retrofitting, or SBER grafting for short. This approach refers to refitting every conceivable or possible urban and industrial site of habitation and extraction into ecological prosthetic semi-open or controlled open systems adapted to each specific climate, geographical and topographical context. SBER grafting would construct the first layers or pathways by using any given community buildings or individual homes, external access and entry points, air vents, water ducts, pipes, windows, thermal gradients via exterior walls and basements, etc. These access and entry points with the natural environment intended for all buildings, whether inside and outside the city, would serve as the first experimental means to create internal artificial biogeochemical cycles inside of built environments. In order to begin the delicate process of slowly conjoining into their given surrounding natural ecosystems. This theory also posits that the primary means for prosthetic or bionic connection point between urban spaces and their surrounding natural environments and their distinct regional and sub-regional micro and macro ecosystems are the biogeochemical cycles. To put it more concisely, a series of theoretical engineering models designed with the eventual full-phased integration of all modern urban, industrial, energy, agricultural and information systems of what is often called the technosphere into the fabric of the biosphere itself. In order to create an ecologically regenerative prosthetic membrane dynamic using a portfolio of separate yet complementary ecological industrial processes based on systems I have invented for each biogeochemical or planetary cycle-based positive feedback loops. I have developed 18 separate inventions and 8 separate central governing and differential equations described in the physics of ecological mechanics for the sake of the introductory purpose of this research paper. To that effect, this PhD prospectus will only limit itself to exploring just 2 ecological mechanical equations and only 3 brief outlines of inventions in the form of a standard symbionic, UENP, buildings and a hydrological cycle demonstrating the basic idea of urban natural biogeochemical symbionic exchange. The central bionic point of connection for natural and urban symbiosis is the biogeochemical or planetary cycles as previously alluded to. In any future academic committee or science peer review context, in order to satisfy any justly rigorous skepticism or the curiosity of the reader of this paper at the very least provides a written description, albeit brief, because of the introductory nature of this research paper, pertaining to the general outlined mechanics of how these naturally linked artificial internal biogeochemical cycles inside any given built environment could viably work. These internal nature interfacing urban biogeochemical cycles would be ideally experimentally developed using a series of highly specialized and modular hydroponic, aeroponic, aquaculture, and other indoor horticulture techniques already being implemented and scaled at varying levels in the fields of urban agriculture, as well as agroecology and agroforestry. After reading this paper, it is the goal that it will be made obvious that Symbionic's UENP is wholly different from all pre-existing, sustainable, and biomimetic architecture and subsequent urban housing, industrial, agricultural, waste treatment, energy, and information communication system designs. Symbionics, UENP, is the first theory to propose the novel idea of buildings and all of their connected energy, and/or this context even literal caloric needs agriculture/food production and distribution, industrial i.e. manufacturing of goods, services, and materials, as well as waste management, and telecommunications, internet, or phone-based communication, etc., into the very cyclical planetary processes that maintain a life-conducive environment on the planet. The next 4 pages will be dedicated to how Symbionic's UENP has envisioned, theorized, will be dedicated to how Symbionic's UENP has envisioned, theorized, and rudimentarily implemented, at least in a basic digital environment, showing how these buildings and other urban structures can physically and energetically participate in the biogeochemical cycles. This is approached by utilizing their own internal artificial biogeochemical cyclical production and connecting it to the surrounding ecosystems and their natural biogeochemical cyclical rhythms. It is my intent that upon the positive or relatively positive reception of this paper to a scientific and engineering audience in the architecture, planetary and environmental sciences to produce a second paper. This second paper would describe and explore in detail the exact mechanics of each system and device I have developed for each biogeochemical cycle, participation with every possible foreseen ecosystem, niche integration variable. 2 fundamental equations for symbiotic integration between the technosphere and the biosphere. First, the equation for natural urban. Biogeochemical symbiosis. Static state. 1.2. The equation for natural urban biogeochemical. Symbiosis. Dynamic state. See lectured theoretical explanation of the symbiotic equation for natural urban biogeochemical symbiosis in both their static and dynamic states here. Link. The equation for natural urban biogeochemical symbiosis translated into calculus or physics derivatives for solving coefficients or variables for specific ecological mechanical vectors. ESIM, symbiotic effective ecological integration of any urban structure or space. M plus E plus I, TEC, the exchange rate of matter plus energy plus information divided by the specific timed biogeochemical cycle interval TBCI and time variables, time. The TBCI is an engineering principle that also can function as the primary variable of this equation. The timed biogeochemical cycle interval, TBCI principle, is a theoretical method for preventing natural, elemental, and environmental erosion of a symbiotic building or home's material and structural integrities, while at the same time preventing biological and ecosystem fouling that mirrors the metabolic rest that all natural organisms need to maintain internal homeostasis. CNBC equals the conservation of natural biogeochemical cycles. A-2Ls, regeneration of conserved, ecological restored, or bioremediated biogeochemical cycles in urban areas between wilderness and natural environments. NES yields the ability of any given building to fulfill a positive or successfully regenerative function or integrated ecological niche between the urbanized and natural environments over time. To TBCI, yield timed biogeochemical cycle interval, a soft robotic design and retrofitting implementation engineering strategy to prevent any given building or urban environment's premature material degradation and structural integrity compromise through organic matter, energy, and information exchange over time. It is also a metabolic engineering strategy that mirrors or emulates the natural metabolic rest that all organisms and ecosystems must partake in. to prevent premature breakdown of the organism or ecosystem. The dynamic of this equation through the TBCI variant of the time variable of the central symbiotic equation also acts as the primary anti-biological fouling and microbial ecological fouling of the artificial internal biology, chemical cycling, soft robotic interior and exterior of any future natural and urban environments. This is the central equation underlying my entire body of theory of symbionics or urban ecological niche prosthetics and all of my subsequent accompanying inventions and designs. It is the E/mc square of Symbionic's UENP. The equation for natural and urban biogeochemical symbiosis mathematically and physically describes through ecological mechanics that the successful integration of any single urban spaces or structures is directly proportional to the exchange rate of matter and energy and information divided by time it takes to exchange matter, energy, and information or process data between built and natural environments. This engineering design principle also obeys the three laws of thermodynamics by accounting for and preemptively offsetting the potential for premature, accelerated entropic degradation on any level. The following AI-generated images are based off of the detailed written schematics of my inventions and their mechanical functional workings of an imagined future, symbiotic NP building or home. These AI illustrations, generated by these written schematics, are meant to demonstrate the natural and urban biogeochemical symbiosis equation in action. In this way, the equation for natural urban biogeochemical symbiosis can be considered to be a foundational general law that all symbiotic buildings and systems must obey. This last AI-generated schematic shown below demonstrates a symbiotic UENP, natural urban biogeochemical cycle, linked-based hydrological cycle between a building and surrounding aquatic or semi-aquatic natural environments, aka a symbiotic hydrosphere. In any near or far future experimental implementation, it is my current theoretical position that the successful development of internal artificially generated biogeochemical cycles of a given home or building will most likely have to iteratively develop and optimize at least one artificial internal biogeochemical cycle at a time. This is essential to prevent material and mechanical fatigue of the home, building, or given urban space in question. It is the current experimental strategy to eventually fully integrate all of the artificial internal biogeochemical cycles together before integrating with the natural biogeochemical makeup of ecosystems into a successful series of micro and then macro ecological niches. Footnote: the restricted use of these AI-generated based images is due to traditional CAD-based software for civil engineering, landscaping, and traditional mechanical engineering not being currently sufficient to simulate ecologically and biologically integrated urban and industrial systems, of which I had to invent the idioms and axioms from scratch to describe such unique forms of ecological niche prosthetic systems, i.e. systems and devices that don't exist yet physically, nor is traditional CAD-based software capable of representing the unique material and energy flows that could be modeled based on mechanical systems that have only just been theorized. First, the symbiotic equation for deep learning effectiveness and the Symbiotic AI Efficiency or SHR-ASP protocol. eSym its overall symbiotic effectiveness over time. Represents a scaling constant. DSMADO's symbiotic quality of generated or corrected AI data. Partial E, partial C are the negative derivative of energy used in relation to computational complexity of a given LLM artificial intelligence. This equation measures the exact rate of energy usage as overall consumption decreases with the increasing or compounding computational complexity. The derivative of this equation provides a specific identified metric for an optimized and more energy-efficient AI model for future experimental refinement and expanded applications. This negative coefficient also represents the usage of digital or computational waste as a resource input molded after industrial symbiosis, i.e. the harnessing of a stored or pre-existing database of incorrect, poisoned, and corrupted LLM AI data to be used as a corrective mechanism to prevent data poisoning or corruption, as well as computational complexity in relation to energy usage and overall gained efficiency. Footnote: while this equation doesn't pertain specifically to the cycling of biogeochemistry between urban and natural environments like the previous central equation, the second equation does, however, demonstrate the underlying feasibility of high-energy, high-entropic and extractive-based infrastructure like LLM AI data centers and server farms to utilize its own waste as a corrective ecological and environmental mechanism that could tend towards ecological remediation. Experimental Evidence Section. Zaplatar N. SHR-ASP Sim1 2025 Research Paper. Nathaniel Zaplatar's Symbionic's UENP R&D Journal 2025-2026. Zaplatar NSHR-ASP Sim2 2025 Research Paper. Nathaniel Zaplatar's Symbionic's UENP R&D Journal 2025-2026. Zaplatar N. SHR-ASP Sim1 2026 Research Paper. Nathaniel Zaplatar's Symbionic's UENP R&D Journal 2025-2026. Zaplatar N. File where C uses Symbi, downloads Biosphere percent 202, Sote percent 20 green, 20 AI 20 versus SAS 20 SRN. Symbionic's percent 21 Young PDF. Nathaniel Zaplatar's Symbionic's UENP R&D Journal 2025-2026 linked. Zaplatar N. File C uses Symbi, downloads SOTA Ascent 20 green, 20 AI per 20 VS percent 20 Symbionic's 20% 2. Nathaniel Zaplatar's Symbionic's UEN R&D Journal 2025-2026 link. Early rudimentary, experimental, and empirical verification of the symbiotic equation for deep learning effectiveness in a digital surrogate LLM AI-based environment. Lead researcher Nathaniel M. Zaplatar. Subject area Symbionic's UENP and Ecological Planetary Cybernetics AI Ethics Safety. Abstract. The following two documents listed above thoroughly details a controlled digital and LLM symbolic language simulated environment that was used to stress test the symbiotic HRASP protocol and its symbiotic equation for deep learning effectiveness. This was achieved experimentally by utilizing a complex, large learning language model to act as a surrogate or simulated unconstrained or rogue artificial intelligence model. These three experiments, conducted in the same manner, all sought to verify repeatedly that the equation and the protocol's ability to functionally enforce in a digital environment. A pathway towards high-complexity information generation with reduced overall energy consumption measured in its carbon footprint, which reduced incorrect, corrupted, or poisoned data responses. The specific experiment involved simulating the design tasks of one of my inventions, in this case, the Symbiotic Subterranean Re-Earthing Network, SSREN. The LLM AI in this case Google Gemini attempted to create a digital environment to execute the designed tasks, functionality, and overall purpose of the SSREN. Google Gemini simulated achieving the functional goals of the SSRN. The LLM AI experiment used detailed written schematics using simulated, pre-existing, and standardized high-entropy, heavy industry, along with digital information acquisition methods. The result: the introduction of the governing equation into the Google Gemini LLM simulation of my invention caused computational paralysis and forced it to shut down in the second repeated experiment, alongside a verifiable 35.7% overall reduction in high-entropy generated intellectual queries or prompts. The experimental implementation of the symbiotic equation for deep learning effectiveness reduced the CO2 or carbon footprint of the use of the Google Gemini LLM digital environment by approximately 98,175 kilograms of CO2 per cycle. Closing statements. There's something inherently problematic in the framing of sustainability that implies the best you can aspire to is neutrality, and anything less than that is just part of a degenerative downward cycle. Michael Pollan, Biomimicry in Architecture. 2016. Disciplines are artifacts of the way we study the world, not the way the world is. Nature is not organized in the same way universities are. It does not fall into disciplines such as chemistry, physics, psychology, and the like. Russell L. Ackoff, General Systems Yearbook 1960. In these final closing statements, I would like to summarize why biomimicry and sustainability in the technology and energy sectors in general are inherently insufficient to meet the needs in order to reverse and stabilize the damage of the Anthropocene or the sixth mass extinction, especially writing this as of January 2026. The theory of symbionics, UENP engineering, was originally intended as a theoretical and experimental branch of biomimicry and ecosystem biomimicry when I was theorizing and designing the first systems and invention designs between the years 2015 minus 2024. Symbiotics, UENP, has now deviated or speciated completely from biomimicry despite the likely promise of the continued potential for advancement and optimizations to create more ecologically benign and efficient systems through biomimetics. It is evident when studying any large-scale or famous example of biomimetic applications, the termite mound-inspired building in Zimbabwe, the kingfisher-shaped maglev train in Japan, air-based moisture water collection nets in Ethiopia, or the attempt to create an ecologically regenerative metric based off of achieving the ecological health of a pre-developed human settlement's ecosystem services in a proposed biomimetic post-developed ecosystem's health. The metrics of ecosystem services is, in the view of this paper, a far too vaguely scientific or engineering-defined set of metrics for an ecosystem biomimetics-based structures intended for full-scale future urban settlements. The introduction of ecosystem services metrics through ecosystem biomimicry has amounted to little more than a design metaphor than an actual design strategy for ecological restorative success in the short or long term. Biomimicry is often claimed by its most ardent supporters to eventually lead to a cascade of breakthroughs. Yet despite all of the major, often cited breakthrough examples, all of which are positive attempts and advancements in their own right, it could be reasoned that standard biomimicry form and ecosystem biomimicry function, that both of their biggest engineering and scientific flaws or blind spots can be crucially identified in two areas. First, the first flaw of biomimicry and ecosystem biomimicry is the intrinsic lack of any physical or energetic means to establish a metabolic exchange required to directly interface with the natural surrounding environments and the plethora of ecosystem varieties. An interface of this nature is required to better quantify and accurately gather biological, biochemical, biogeochemical, and other physical ecological markers indicating improved planetary health from the previous pre-symbiotic ecological health intervention state of any area researched in question. Example, a biomimetic building's interior may regulate heat like an African termite mound, but is void of any means to purify the air from inside the building before being expelled back outside, leading to the same negligible or negative effect on a primary ecosystem service, air. Second, the second flaw of biomimicry and ecosystem biomimicry is the inherent lack of any future integration strategy with other separate biomimetic technologies or systems to work as a unified or semi-unified whole on or at any level. Cybernetic or information intercommunication control. Example, a tidal power turbine shaped like a whale fin may reduce harmful sonic pressure waves but has no means of sharing real-time marine biology data to track migration patterns of different marine animals and adjusting its sonic, harmful vibration frequency range unique to each specific aquatic species or any other unforeseen ecological harmful effect in its vicinity. The theory of symbiotics, UENP, not only already provides the first theoretical framework to directly augment all at the same time, arguably a much better emulation of the natural world. The theory of symbiotics, UENP, not only already provides the first theoretical framework to directly augment all urban, infrastructural, industrial, agricultural, biotechnological, energy production, and information systems directly local into ecosystems and the planetary biosphere of Earth, while at the same time, arguably a much better emulation of the natural world than standard form or function biomimicry because of the very fact of its cybernetic communication and information positive feedback loops built in technologies to directly give, while at the same time, arguably a much better emulation of the natural world than standard form or function biomimicry because of the very fact of its cybernetic communication and information positive feedback loops built into the designs of each symbiotic UENP technologies to directly give back equally whatever it takes from the environment at relatively low entropy states. It was the core aim of this 16-page research paper that I have written to demonstrate the theoretical and early experimental superiority of symbiotic-based urban and natural symbiosis over standard sustainability, including most importantly, biomimicry.